Okay, calculus, this is the second page of your notes having to do with continuous piecewise functions. We are going to do example number 2. All right, we are given a piecewise function. If you notice, we have a variable in there, k, kx squared, for all x is less than 2. Less than 2, that is, of course, our left function. And our second branch is the absolute value of x minus 3 plus 4. That is for all x is greater than 2. Greater than 2 is to the right of the 2, right of 2. That is our right function. So our goal is to find the value of the constant k. So this k right here, k represents a constant. Remember, constant is a number. So we want to find the value of the constant, the number k, that makes the function continuous at x is equal to 2. So let's review the definition of continuous. There has to be a y value, and the second step is what we focus on. There has to be a limit. In order for a limit to exist, the left and the rights have to be the same. So we focus on that. So I'm on step 1. The first step is to find the left limit. In these examples, you have to use correct calculus limit notation. So it looks like this. For the left limit, it's the limit as x approaches 2 from the left. We use our left function, which is kx squared. Okay, now we have a limit problem. We can do direct substitution. We are plugging 2 in for x. So be careful, we're plugging 2 in for x, not for k. So it looks like this, k times 2 squared. And if we simplify that, we get k times 2 squared, which is k times 4, and we write it like this, 4k. That is our left limit. Oops. Okay, the second step. Now we find the right limit. And again, correct calculus notation. The limit as x approaches 2 with a little plus sign, we use our right function, so the absolute value of x minus 3 plus 4. Now we have a limit problem. We can do direct substitution. We can plug that 2 right in for x. So it looks like this. The absolute value of 2 minus 3 plus 4. All right, so the absolute value of 2 minus 3, it's the absolute value of negative 1 plus 4. The absolute value of negative 1, of course, is positive 1 because absolute value makes everything positive. So 1 plus 4 is equal to 5. So 5 is my right limit. Okay. Now, in order for the limit to exist, the left and the rights have to be the same. So that's our third step. Set the left and right limits equal to each other, and then we solve for k. So our left limit is 4k. We set it equal to our right limit, which is 5, and then we solve for k. The easiest way to solve for k here is to divide each side by 4. So those cancel. My k is equal to 5/4, or 1.25. Okay, there is our k value. Now we're going to check our work. Check this out. We go to our calculator. We go to y equals, and we plug in the piecewise function, but we put in what our value of k is. All right, this is 1.25. My 1 got highlighted. But we put the 1.25 in for k. And we graph the piecewise function, 1.25 x squared, division, parentheses, x is less than 2, and then we put in our second branch, absolute value of x minus 3 plus 4, division, parentheses, x is greater than or equal to 2. To get to absolute value, you guys, you just hit math, and then you arrow over to number, and it'll be right down below ABS. All right, so first step, you graph the piecewise function, putting in what you think k is. The second step, you go to your table. You start your table at what your dividing point is, and you go in very small increments. Remember, when we're setting up a table to find a limit, we want small increments. Third step, right here. We go into our table and we arrow up. Here we go. So now we do the 3 steps for continuous at 2. The first step, is there a y value? A y value, absolutely. Look, check it out. At 2, there's a y value right there. I'm going to highlight it. All right, so there it is. Yes. It is equal to 5. The second step, is there a limit? All right, we come at 2 from the left and the right. As I come at 2 from the left, my y values are getting closer and closer to 5. As I come at 2 from the right, my y values right here are getting closer and closer to 5. So by looking at my table, yes, it is equal to 5. And of course, the third step, f of 2 is equal to the limit as x approaches 2. All right, so there is a y value, 5. There is a limit, left and rights are 5, and they are the same. Check. And then finally, of course, look at the graph. Here's a picture of the graph. If I put my vertical line through 2, hey, I can draw that graph without picking up my pencil. All right, great way to check your work. All right, thanks, calculus. Try the homework now.